Let's talk about Swift application. After we've heard a lot about AI, user experience, front-end technologies, we are going to move much further to the back-end. I guess this is the first back-end talk today. There's another one from Sasha after lunch. My name is Michael Dürig. I work for Magnolia as a developer since almost 6 years now, and I've been in the industry for almost forever. Let's not talk about me, let's talk about Swift application. Swift application is a project we are working on here. It's a new project at Magnolia we've been working on for a couple of months now. Its aim is to improve and make more flexible the publishing experience that you have when you publish your content with Magnolia. We are going to look at publishing in general. We're going to look at publishing, how it works currently with Magnolia, before, just to set the stage and get everybody on the same page here. Then we talk about Swift publication, what it is, how it works, the architecture, the options that you have, the implementation options that you have. We have a quick demo, a pre-recorded demo. I was not allowed to do live demos. Outlook, where we want to take it further from here before we then conclude. And hopefully have a bit of time for questions. Let's get right into it. Publishing, I just read that off the slide. Publishing means transferring content from a Magnolia author instance to public instances so that visitors to your website can access the content. It's probably trivial, but I want to make sure everybody knows what we're talking about when we say publishing. Publishing is transferring the content that the content author created on the author instance over to the public instances, so it becomes available to the visitors of your website. This is how publishing currently looks in your instance. It's quite simple, actually. On the left side, you see a Magnolia author instance connected via HTTP to Magnolia public instances. When a content author is ready with editing some pages, creating some pages, he publishes the pages, which will create a version of that page, which means there's a version of that actual state being persisted on the author instance in the Java content repository, and using, and this is a bit of a crucial part, using the Java content repository versioning feature, which turns out to be slow. And once that happened, that version of the page is sent over via HTTP to the public instances, where it is being stored locally, again in JSON, not in the version store, just normal Java content repository content, and being made available to your visitors. The public instances will reply back to the author instance, and only then will the author instance be available for further editing for the content editor. So there will be always some sort of a lag while this process is going on in the background. Well, this works well. It works out of the box. It's relatively simple, but there is issues that you might run into when you want to scale it up. The whole thing is quite monolithic. The versioning is quite heavily or quite tightly tied to the publishing process. The JSON version store is slow, we know that. The author waits, I mentioned that already. The author needs to wait for the public instances to apply the content and reply back that yes, I'm done, which can take some time. And we can work with a fixed number of public instances in your deployment, basically. So this all creates some scalability issues when you have a lot of content to publish, when you have a lot of public instances, you have to wait for all of them, or when you publish very frequently, you can run into scalability issues. So these are the issues that we identified through various projects, various customer projects, various feedback that we got. And we looked at what issues can we solve, how can we solve them. What we came up with is basically, let's break that monolith. and take out these critical bits into external services that we can individually scale. So we externalize the version store. Instead of having the version stored in the Java's content repository versioning feature, we put the versions into an external store now, which allows you to take some load off the author instance actually and offload that to an external store. We decouple the public instances from the author, so when we publish now, the content will be sent to the public instances, but the author will stay available for editing, and eventually you get updates to the author instance when the content has been received by the public instances. There's no need to wait anymore with the authoring. And we added to the whole thing some external orchestration to further decouple the various systems. So if, for example, if the author instance needs to go down for some maintenance, the ongoing publications will not get lost. They will still go on, and the author instance will catch up later when it comes back up again. From a bird's eye perspective, how does that look? We have, again, on the left side, the Magnolia author instance, but you see that then there in JCR, there is no JCR version store anymore. The version store is now in the middle of that slide. It's an external store. On the right side, we again have the public instances that have their local JCR without any versioning. And on the top, we have this orchestration mechanism. In this case, if the content author is ready for publishing some content, the content will be pushed to the version store. The orchestration mechanism will be made aware of that. It will notify the public instances. Those will pull the content from the version store. When they applied that new version, that new content, they will notify via this orchestration mechanism the author instance, which will then show some sort of a notification or update the page status in the Pages app that that content is now published. All these various components come with various implementations. So for the orchestration, there is the possibility that you use the basic REST calls, or there's a more sophisticated way to use RabbitMQ with the queuing system in the back. For the version store, we offer S3 or Azure for the external version store, where you can store the versions. We also plan to offer, there is only prototyping for now, what we call the blob store. This is basically storing your versions collocated with the author instance again, but not in the version store of JCR, but in a separate way in the file system, maybe. And we're going to see in a minute why this might be interesting. And obviously, there's the do-it-yourself option. If you want to have your own version store, integrate your own version store, that is not very difficult to implement. There is an API which is very small actually. You can implement your own quite easily. Right, from here, let's look at various implementation options, how you can mix and match these components and what that actually brings you. We start from small, so small meaning not a lot of external infrastructure, to the biggest option where you have to provision more external infrastructure. This is kind of gives you a way to choose the benefit cost ratio for what your solution actually needs. So the most simple one looks like this, and it has a striking similarity to what we've seen on one of the first slides, where we have this tight coupling. We have Magnolia on the left, the author instance on the left, we have the public instances on the right. We use REST for coordinating the publications. We send over the content via these REST calls, and we store the versions. Not in JCR, I just call it a blob store. We store it co-located again with the author instance. So why would you want to do that? I mean, it looks pretty similar to what we already have. The reason for that is it is, first of all, already a bit more scalable. We don't have the tight coupling anymore. We just send the content over to the public instances. We don't wait for the public instances to reply back, just asynchronously pull them for status updates later on. And storing the content as a blob versus storing it in the Java Content Repository version store is much more faster already. That's not the only reason. The other reason is this is a nice first step in a migration path you might have. If you think of, okay, I want to profit from Swift publication, I want to go into this direction, then, but you're not sure which kind of flavor you want to choose. This is the simplest flavor you can choose, and then you can grow your infrastructure from there. For example, you could, as a next step, replace the version store, the blob version store, with an external one. Take that out of the author instance into an external service, in this case S3, but still use REST for coordination. In this case, no content is going to be sent over the wire anymore, over REST anymore. It's just being pushed into S3. REST does the coordination, telling the public instance there's a new version, please pull it out from there. And if you want to go even further, you can take out that orchestration from REST and implement that via our RabbitMQ connector. So RabbitMQ would take over all this coordination between the author and public instances, which allows you even further deep coupling your instances and taking further load off the author instance. Okay, I guess that's where we have some demos. Yes, there's 3 pre-recorded demos. Let's have a look at the first one, where there is simply the publishing process. It's not very visual, so it's mostly in the back end. What you're going to see is I publish a page, a content tree. So this is publishing. Now I have to go through the workflows and assign the workflow to me and approve the publication. And if you watch closely, you might have seen that the page status, had a quick switch from draft to in progress to published. So this is a new thing you're going to see, because we are not waiting and blocking the author instance. We have this intermediate state of the publishing is currently in progress. We're going to see this a bit more in the next demo, or in another demo in a minute. Let's look what happens if an error occurs. I'm simulating an error here by just killing the database of one of the public instances and publishing the content. So again, approving the workflow. And in this case, the status will switch to error. If you hover over with a mouse, you get an error message. It's telling you there's something wrong on the public one instance. I'm spinning up the database again, trying the whole thing again. So again, publishing the content tree. And it should now go to green and published. And as a last one, a bit more interesting maybe, if I switched off a public instance completely, so one of your publics is down, I publish the content. What happens is it will wait for 2 replies. I have 2 public instances. It will only receive 1, so the status will stay in progress. I can switch on the public instance again. It will now wait for the public to come back online. The public instance will pick up the publication from the orchestration. In this case, that was RabbitMQ. And once the public instance is back up, it will switch from in progress to published. That happened just now.
Cool.
Okay, so much with the demos. Quick word about performance. This is some preliminary numbers where we compared Swift publication performance to standard publication performance. On the left side, publishing almost 5,000 pages took 100 minutes. On the right side, with Swift publication, we could cut that down to just 40 minutes. And I would assume that the number goes further down with some recent optimizations that we've done to the code. This measurement is a couple of months old already. The numbers were taken with 3 public instances. We had S3 in the background, 3 public instances in 3 different geographical regions. Right. Before we conclude, let's have a quick look how we could deploy this in Kubernetes, focusing on scaling up and down public instances. That's something that I mentioned in a introductory slide, that we have a fixed number of public instances currently, mostly in Magnolia, and that we start introducing the ability to add public instances and remove public instances dynamically. With Kubernetes, what you can do if you deploy Swift publication there is you can configure your public instances in Kubernetes config map, and then we have that operator. This is a Kubernetes concept. You have this Magnolia message broker operator, which basically sees that, okay, you did a change in that config map. Maybe you added a public instance there. It sees that. What it will do, it will go into the control loop of Kubernetes and try to align the desired state, what you configured in the config map, with the actual state. And that's the custom code in the operator. What it will do is it will connect to RabbitMQ in this case and configure additional queues for the additional public instance, the additional exchanges that are needed there. So we can actually deal with additional public instances. So this is kind of a roadmap towards being able to scale your number of public instances more dynamically. If we go further and talk about satellite clusters, there's no need to read everything on this slide. You basically replicate the setup from the previous slide to your satellites. The only difference on the right side, the satellite clusters in the APAC region or the US region, is there is no author instance. There is only public instances. And the whole orchestration is handled via standard, in this case, standard RabbitMQ federation mechanism that you configure. So you can scale that up to multiple regions via RabbitMQ federation. This is the completely other end of the spectrum, talking about deployments where we before saw Kubernetes, multi-region and everything. This now is your local machine deploying this in Docker. We briefly saw that in the videos, that we can run everything in a local Docker component, in a local Docker setup. This is something that we also want to make available for developers. It's very handy for local development. You don't need the infrastructure. Everything runs locally. You have a local S3, you have a local RabbitMQ. No need to set that up. It's pretty easy to get it running. It's easy to debug things. It's easy to develop your own solutions within that. And it's very handy for integration testing. We actually use that internally for running our integration tests. It's really helpful to us. Okay. For a quick overview and outlook, here's a summary what we are roughly planning to do. It's more concrete to what's happening in the near future, whereas what's happening in the farther future. Things might change, so please don't pin me on that. But we are currently in the process of rolling out the first version of Swift publication using REST for orchestration, S3 for the backend store, for Magnolia 6.2 and for some selected customers there. We plan to follow up not too long after that with 6.3 and releases for 6.3, and also support all the backend version store, Azure, one example, and the ability to implement your own. Maybe at the same time, maybe a bit later, that's to be decided, we will then also offer the ability to use RabbitMQ for the orchestration mechanism, and we'll also offer ways to migrate between the different setups. In this case, for RabbitMQ, it shouldn't be actually just replacing a Magnolia module. There's no data migration involved in that. It's just a different mechanism there. Blob versioning is further down on the horizon. It's currently in development. We have a couple of prototypes, and we'll be working on that and making information available as soon as we have more about that. And a word about JCR versioning. So like the far horizon would be that we would like to phase out JCR versioning. That's in line with the whole strategy of decoupling ourselves from that single content store and using more dedicated storage backends for whatever we need that suits their actual needs. So to recap, what do you get from Swift publication? What is the benefits you get from Swift publication? For editors, obviously, you can keep editing without interruption. You don't need to wait for publications you finish. You can just keep on going, fire off your publication and keep on editing. For developers, we've seen the various implementation options. You can pick and choose what you need, what you have, what you want. For your organization, well, you can scale your Magnolia deployment to the actual business needs that you have. With that, I'm done. There is a link to the current in progress documentation. There's quite a bit of information there already. You can also go to the documentation site and search for Swift publication. You find that there. It's not linked in the content. You're not going to find it there yet, but you can search for it and you'll find it. And if you're interested in further information, if you're interested in implementation options, previews, live demos, whatever, please get in touch. There is swift.publishing@magnoliacms.com, and yeah, we'll be getting back to you. Thank you.
All right, thanks a lot, Mickey. Are there any questions on Mickey's talk? Oh, there's some questions. Let's get the mic on the floor.
Yeah, thank you for the talk. A question on the migration. We are past users, and the way I would see it, it seems like an adaptation of the Helm chart we would have, and probably the new Magnolia version at that point. There, we expected much more that we need to do to get this.
I would expect the PASS team to help you with a lot of that. I'm not promising too much. Yes, there's a couple of migration steps. If you work with an external data store, the storage format is obviously a different one. We store the whole pages in one big blob instead of like this whole node structure in JCR. We have a migration tool for that. The PASS team is working towards moving to using Kubernetes operators. I'm not qualified to answer all the details there, but we are moving into this direction in general. So yes, I guess there is a lot of support you're getting from us.
Thank you.
I think there was some other questions.
When a new public instance is added, how is the existing published content synced to the new public instance?
Yeah, I thought that. I expected that question. I don't have a good answer now. That's still something we need to work on. That needs to be optimized. But you could think of having a standby instance that then can be added on the fly. This bit that I showed is the infrastructure bit, and then the content bit is obviously something different. But obviously it will work with a standby instance that you then can just add as needed and take offline if not needed. But the content copying is still quite a heavy thing, yes.
Okay, thanks.
That was really cool. Does this work with this architecture with reverse replication? So you could configure the author and say you have a REST endpoint, you post to a publisher and replicate the content back to the author?
Nothing that we looked at just now, but that might be in future projects or in future features, yes.
So any more questions? I think we have a question up here. Vivian?
Michael, thanks for the presentation. I have two questions. First is, so did I get the status correct that it's not usable with 6.3? Or is it just not tested maybe?
We are focusing on 6.2 because the most urgent cases that we want to work on 6.2, but we'll plan to support 6.3 shortly afterwards. Until only a couple of weeks ago, we focused on both work streams at the same time, but then we decided to focus on 6.2 first and catch up with 6.3 later. But 6.3 is actually workable. If you want to see a demo, I can show it live on my instance actually.
And second question regarding the versioning, like if you externalize the versions, will they still be accessible via the API? Like from the Magnolia versioning API or Node API?
There will be a new API for that. The JCR API is for JCR, and there is a version storage API in Swift publication for accessing the Swift publication related versions.
So it will be integrated like in the diff functionality, like you can compare what has changed.
Yes, we integrated that. That's something we just worked on in the last couple of weeks. So the diff functionality is still there on top of the Swift publication API, yes.
Yeah, that's good. Thanks a lot.
You're welcome.
Okay, any more questions? All right, then with that, was there one?
One question. What happens with the transactional publication with this kind of workload? Because as I understand, now it gets stuck until it finishes the publication process, and there is no rollback. There is expected to be some timeout to roll back in the for instance the original content.
Yes, that's true. We focused on this version for now that implements eventual consistent transactionality model. So eventually all the content will be available at all the publish instances. Transactionality is like what you're describing with a rollback or making it available at the same time, or use cases that we consider separately, especially that use case of making the content available synchronously at various public instances is something that other teams are working on and that will be made available separately.
All right, thanks a lot, Mickey.
Yep, thanks again.